Continuing on here in section 8.4, we're going to start off with the take note on page 506, the product of sum and difference. Here, if our first terms are the same and our last terms are opposite, which means the same number but different signs, we're always going to get a squared minus b squared. So our first term squared minus our last term squared. And that's because here, if we were to FOIL this out, I'd get a squared minus ab plus ab minus b squared. Negative 1 times 1 and then b times b. Here, negative ab plus ab cancels out. So all we have left is a squared minus b squared. So again, we can always completely FOIL these out if you forget that pattern. But if you recognize here that we have the sum and difference here, then we can use our shortcut. So in example 4, our shorter form here, because I have a cubed, x cubed, my firsts are the same, my lasts are opposites, one's positive, one's negative, I can take my first, square it, I can take my last, and it's going to be negative, square it, and it's negative because one's positive, one's negative. Here, power to a power means I multiply my exponents, and I get x to the 6th power minus 64. And again, if you didn't recognize that right away, it's no problem. We can still FOIL if you want to. So firsts, outsides, insides, and lasts. But when we combine our like terms, those cancel out. Negative 8 plus 8 is 0, so I get x to the 6th minus 64. Again, if we recognize that this is the product of a sum and difference, we can use our shortcut here. Feel free to pause here and give these a try if you'd like. Here, since my a's are both x's, my b's are both 9, and I'm adding and subtracting, I can use my shortcut. I can take my first squared, my last squared, and subtract the 2. I'm going to get x squared minus 81. Again, to actually multiply this out, it would have been firsts, outsides, insides, and last. But when I combine negative 9 plus 9, I get 0 x's. Those are gone, so I get x squared minus 81. So if this way is more comfortable for you, then go for it. But if we can recognize the pattern here, notice that those are a sum and difference of the same a and b values, then we can use our shortcut. So here, since I have a 6 and a 6, and m squared and m squared, plus and minus, okay, I can multiply these by using my shortcut. 6 squared, I can take m squared squared, and we subtract them. 36 minus, here, power to a power means I multiply, and I get m to the 4th. The difference between these and what we did in the first part of this section, guys, is that when I had 6 plus m squared, I was taking it times itself. So the only difference here is a sign in the middle of that second term. And what it does is when they're the same sign, I have to multiply these together and double it. And I would have a positive last term. So that's a good way to check. Are these going to be the a squared plus 2ab plus b squared, or are they going to be a squared minus b squared? Well, if we check our last term, if we'd multiply them together, a positive and a negative, and get a negative, okay, this is the route we go. If we multiply a positive times a positive and get a positive, okay, don't forget that we'd still have that 36 up front, then we know we have to have that middle term as well. So only if we have one negative and one positive will those outsides and inside terms when we FOIL cancel. Here, my firsts are the same, My lasts are the same and opposite signs. I'm adding and I'm subtracting. So I take my firsts, square it, take my last, square it, and because I'd have a positive and a negative, I'm going to subtract here. Remember, we take our squared to both pieces here. So 3 squared is 9, c squared, minus 4 squared, 16. And that's just a little bit of a shortcut to use here. If you recognize it, again, if you didn't, you still could have FOILed out firsts, outsides, insides, and lasts. But my outsides and insides would have added up to 0, so I didn't need those pieces here. In example 5, we're going to use mental math again. So instead of taking 64 times 56 or just typing in our calculator, we're going to try and do this mentally. So 64 is close to 60, and I can get back to 64 by taking 60 plus 4. I just rewrote 64 in another way. 56 is close to 60 as well, but to get back to 56, I have to subtract 4. 60 minus 4 is the exact same thing as 56, it just looks a little different. And what this lets me do, guys, is it lets me use our new property. So because I have the exact same firsts, and my lasts are opposite, which means same number, different signs, I can square my firsts, subtract, and square my lasts. So 6 times 6 is 36, they each have a 0, so it's 3600 here, minus 16. It's going to give me 35. If I take 16 away, I already borrowed there, and I'd have 84 left. So 35, 84. Again, we're trying to break our numbers down into pieces that are a little bit easier to work with. It's easier to work with numbers that have zeros at the end than it is numbers like 64 and 56. And if we can get them to the same place, 60 and 60, and 4 and 4, we can use our shortcut. Again, first squared, last squared, and then because one's positive, one's negative, we have to subtract. From there, we can simplify. Feel free to pause here and give this a try if you'd like. We're looking here, we have 52 times 48. Both of those numbers are really close to 50. So I'm going to try and start from 50 and get back to 52. In order to rewrite 52, I'd have to take 50 plus 2. 50 plus 2 is the exact same thing as 52. 48, again, we said both these numbers are close to 50, so we're going to try and start at 50 and get back to these numbers. 50 minus 2 is the exact same thing as 48. So here I just wrote 52 differently and 48 differently in ways that make it a little bit easier to multiply. So 50 and 50, same firsts, I can square that. 2 and 2, same lasts, I can square that. And because one's negative and one's positive, I'm going to subtract here. 5 squared is 25, and then they each have a 0. 2 squared is 4. Here, I get 2496 when I take 4 away from 2500. And there we have it using mental math. Okay, again, that doesn't mean you can't write anything down. It just means that we're not going to take 52 times 48, carry, and work like that. We're also not just going to type it right in our calculator. So that's kind of the idea there. What number can we get these two that it's close to, and then how do we get back to there, and then use our properties. Quick recap here of section 8.4. There are special rules for simplifying the square of a binomial or the product of a sum and a difference. Again, we don't have to use these properties, but if we recognize them, it's just going to save us some time. But we can always still just FOIL them the same way that we have, or use a table, or whichever method you preferred when it came to multiplying binomials. And that's all I have for section 8.4.